Our first sensor we used on our robot is our encoders. We created functions for the different situations that the encoder has, which is implemented in our drive-in function. Our drive-in function is combined with the usage of the voltage sensor, encoders, and IMU. We use the IMU that is integrated on our rev hubs, which helps keep the robot driving straight during autonomous and teleop. The second image is where the angle correction happens. If it notices that it isn't staying at 0 degrees, then the robot will make one motor go at a faster speed so it can correct and straighten itself. Our rev hubs also use the voltage sensor for the flywheel and our drivetrain to give consistency for a speed at a given spot even though the battery level changes. The next sensor we use is our Logitech webcam, used for detecting the randomized stack to place the wobble goals in the appropriate depot. We have it in a function in which it does all of the math to see if there is no rings or are rings, and if there are rings, then how many. Once it determines how many rings there are in the initialized period, it would then choose one of the three specific cases, whether it's A, B, or C, and then runs the code under them. We also have integrated PID for our shooter. It tracks velocity using encoders to keep consistency. We have integrated this with our voltage sensor to give more accurate results. In our autonomous, it does the following. Place the wobble goal into the appropriate depot, strafe over to shoot the power shots, in which we get 1 or 2, but still work on finalizing it to hit 3. We then come back around the wobble goal and place that into the appropriate depot and park. We have also integrated a few driver enhancements to make our driver's job easier. With the press of a button, we have the robot attempt to shoot all 3 power shots. This is simply taken from our autonomous to give the same results, and are currently working on getting the 3rd power shot. Here is the code for it. Another handy feature that we have included in our robot was an unjamming button. When the button is pressed, it puts the intake in reverse and spins the flywheel motor in low speed to keep the flywheel free of any stuck rings. This feature leaves the flywheel running even after the button is pressed, so when we intake the next set of rings, we have them just come in free of contact from the flywheel until we start spinning it for shooting.